The 1997 typhoon season. Enso dominance and teleconnections. The 1997 season was dominated by one of the strongest El Niño events on record. Key features included exceptionally warm SSTs in the eastern equatorial Pacific exceeding plus 2.5 degrees Celsius anomalies, strong westerly wind anomalies at low latitudes, especially across Micronesia and east of the 180 degrees east meridian. The Southern Oscillation Index SOI plummeted to extremely negative values. Eastward shift in the monsoon trough and genesis locations due to El Niño-induced equatorial Kelvin waves and suppressed convection near the Philippines. Supporting oscillatory factors, MJO Madden-Julian oscillation was not the primary driver, but may have helped modulate intra-season variability. Equatorial Kelvin waves likely contributed to persistent westerlies in the early season cyclogenesis east of 160 degrees. And on this graphic, the season overview, the intensity, frequency anomalies, you can see of the metric of total tropical cyclones, typhoons, super typhoons and tropical cyclone genesis east of 160 degrees. In 1997 we had 33 total tropical cyclones, which is above average on the climatology of 31. We had above average of typhoons, we had above average of super typhoons, and we had above average of cyclone genesis east of 160 degrees. The 11 super typhoons broke the previous record, 7 in 1971, 1987, 1989 and 1991. This was the highest number of typhoons since 1971. The track and pattern anomalies, genesis patterns, most of the cyclones formed east of 140 degrees, with 11 forming east of 160 degrees. Only one storm made landfall in the Philippines, which is atypical. Track types. Tracks were shifted eastward, then recurved northeast due to persistent subtropical ridge repositioning from El Niño. Scientific phenomena observed. Unprecedented eastward shift of the monsoon trough. Average genesis moved 20 degrees east. Persistent low latitude westerlies in June to October led to high tropical cyclone formation east of the dateline, reduced landfalls in Philippines and mainland China, large slow moving storms with very intense expansive wind fields, fewer simultaneous storms than usual despite a high total account, a unique sequence. Comparative analogues in historical context. Strong analog year is 2015, also a strong El Niño year with frequent intense and eastward forming typhoons, such as Typhoon Maisak and Typhoon Sudalo. Both 1997 and 2015 had eastward shifted genesis, strong intensities and reduced western Pacific landfalls. Probability and rarity. Based on known teleconnections, such a high concentration of super typhoons 11 is less than 2% annual likelihood based on historical records of 1960 to 2020. It would require a major El Niño of an ONI value greater than plus 2.0, persistent eastward monsoon trough, warm SSTs exceeding 30 degrees over a broad area, weak MGO suppression in active phases. Of the season, there were notable Category 5 super typhoons, and this table below will show you all the significant storms of the season. Of these, Ivan, Joan, Packer, Oliver and Keith all reached Category 5 intensity, and many of them were formed east of 160 degrees. You will see that mentioned a lot of times because it is very interesting, unique and quite a notable phenomena that should be talked about that is not ever really mentioned in any case study. Typhoon Keith. The meteorological behaviour. Keith underwent rapid intensification on October 30th to 31st, with satellite Dvorak estimates skyrocketing as a pinhole eye emerged and contracted rapidly. This small eye, estimated less than 15 kilometers in diameter, was surrounded by an intense ring of convection, a textbook sign of a very efficient energy conversion. The rapid intensification. Keith benefited from high ocean heat content, exceptionally low shear, and vigorous upper level outflow, especially poleward toward a mid-latitude trough. The tight core allowed for maximized angular momentum conservation, spinning up winds rapidly like a figure skater. The eye formed on late October 29th and became perfectly clear on the 30th. Microwave imagery showed a symmetric convective ring. Infrared temperatures in the eye wall plummeted to minus 80 degrees Celsius. The storm passed just 55 kilometers between Rota and Tinian, scraping them with the eye wall, but the core remained intact. Had the track shifted 15 kilometers east, damage would have been exponentially worse. Legacy: over 800 homes were damaged, but Keith became a laboratory example of how compact typhoons can rival the destructive power of larger ones, and why size is not a requirement for intensity. Typhoon Paka. Paka intensified in early December as it traversed a warm pool of greater than 30 degrees Celsius SSTs in the Western Pacific. A large symmetric eye eventually formed after multiple eye wall replacement cycles. The typhoon produced a wind gust of 236 miles per hour or 105 meters per second at Anderson Air Force Base in Guam. It is believed to be the strongest ever recorded on land, though the anemometer failed shortly afterwards and is also skepticized for its data. Paka's outflow channel extended nearly 1,800 kilometers eastward, tapping into upper level divergence enhanced by the El Niño jet stream. The eye briefly developed mesovortices. Swirls inside the eye wall can only be seen in the most intense systems, often associated with cyclic bursts of convection. If in the Atlantic, it would rival the most intense hurricanes ever, akin to Hurricane Dorian or Wilma. Despite the immense power, there were no fatalities. Guam saw 10,000 buildings damaged or destroyed. Typhoon Ivan. Ivan was one of the very few 1997 typhoons to directly hit the Philippines, making landfall over northern Luzon. Ivan developed a textbook stadium eye, a sloping eye wall seen in Category 5 storms. The eye diameter was approximately 30 kilometers, surrounded by a symmetric CDO, central dense overcast. The storm rode along a well-ventilated upper-level ridge with dual outflow channels, aiding in its intensification despite increased land friction later on. It caused severe flooding, destruction of 1,700 homes, and crop losses due to the slow traverse. Typhoon Joan. Joan remained a Category 5, greater than 140 knots, for 4.5 consecutive days, an unprecedented achievement at the time. What fueled this? It sat atop a region of greater than 30 degrees Celsius SSTs with low shear and was isolated from other major steering disruptions. Uniquely, Joan and Ivan coexisted as simultaneous Category 5s, a rare synoptic setup which maintained through enough distance to avoid the Fujiwara interactions. Joan's eye remained mostly circular and cloud-free. It even shrank to less than 25 kilometers, suggesting an intensifying or steady state cycle throughout. If Joan happened today, it would likely cause international attention for its longevity alone, challenging metrics for satellite-based intensity estimation. Typhoon Ginger. Ginger recurved and accelerated northeastward, eventually transitioning into an extratropical cyclone, but this wasn't the end. A rare path, the system's remnants moved across North Pacific and impacted the Pacific Northwest in the US, with strong winds and a landfall with lots of precipitation, a rare example of a tropical origin storm affecting the continental US west coast. During extratropical transition, Ginger's warm core decayed, but its vorticity stretched along the jet stream axis, helping it punch through the atmospheric stability of the coast of Oregon and Washington. Despite being post-tropical, Ginger's core remained compact, helping its spin survive transoceanic crossing. Typhoon Oliwa. Oliwa strengthened from a tropical storm to Category 5 in under 36 hours. That's more than 60 millibars of pressure fall at a near doubling of wind speed. The physical explanation is really that they were again high SSTs, very moist mid-levels, and a developing anticyclone aloft allowed latent heat release to be rapidly vented, a key to rapid deepening. It originated east of the dateline and eventually struck Japan, crossing thousands of kilometers, highlighting how El Niño shifts genesis eastward, and may even allow for that longevity in these tracks. Microwave data showed textbook concentric eye walls forming, a feature often seen during plateauing or re-intensification phases. Typhoon Winnie, its eye grew to 370 kilometers in diameter, among the largest recorded globally, suggesting a vast storm with a massive wind field. Even as a central pressure leveled off, Winnie's core went through at least 2 eye replacement cycles, expanding the storm size significantly and helping it maintain destructive power even if the peak winds slightly declined. Record floods in China, the enormous eye and the outer wind field made it particularly damaging for the coastal infrastructure and the prolonged rain bands that were inland. Typhoon Rosie. Rosie didn't make headlines, but it reflected an important climatological signature of the 1997 season. Eastward shifted formations and recurving before major land impacts. Satellite images captured well-organized banding features and a mid-sized eye during its peak, suggesting a structurally healthy typhoon despite its limited impact. It exemplifies the silent majority of recurving typhoons that help modulate oceanic heat content and inject momentum into the mid-latitude westerlies. The lasting legacy. The 1997 season serves as a benchmark El Niño year, shaping operational and climatological understanding. Elevated ENSO awareness post-1997 led to improved genesis forecasts and seasonal outlooks. It exemplified the non-linear link between SST's anomalies and the TC frequency intensities, especially under anomalous synoptic setups. What this really means is that whilst warmer SSTs provide more energy for cyclone formation and intensification, the response isn't always proportional. For instance, a slight increase in SSTs can lead to a significant rise in the cyclone intensity under certain atmospheric conditions, but further increases may not yield the same effect. Anomalous synoptic setups. These refer to the unusual large-scale atmospheric patterns such as shifts in the jet streams or pressure systems which can influence paths and development. In 1997, the strong El Niño event altered atmospheric circulations, leading to changes in cyclone genesis, locations and tracks. This will be a season to remember, one that is often forgotten, but one that will always be remembered by the researchers.